So, Chapter 3.2, Day 1, Complex Number. The imaginary unit I. Not all quadratic equations have real number solutions. For example, x squared equals -3 has no real number solutions because the square of any real number is never a negative. So, for example, if you even have a negative number in the beginning, and if you square it, it's going to be always positive. It means whenever we square any number, it cannot result as negative. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I, defined as I equals square root of -1. So note that I squared will be equals to -1. So remember, when I square equal, I is -1, and if you square this both sides, so if you square this both sides, square and square root cancel, I square becomes -1. So I square is -1. The imaginary unit I can be used to write the square root of any negative number. The square root of a negative number. Property. If r is a positive number, then square root of a negative r is square root of -1 times square root of r. Square root of -1, we already defined that square root of -1 is I, so it's going to be I, and square root r. So answer is I square root r. By the first property, it follows that I square root r square is going to be I square times r square root r square. Now we know that the I square is going to be -1, so it's going to be -1, and square root of r is just r, so it's going to be -r. So example, negative square root 3, so that's going to be I for negative and square root 3, so the answer is I square root 3. The next is I square square root 3 square. I square is negative and square root of 3 square is 3, so -3 is going to be your answer. Example number 1, finding square roots of numbers. So letter A is a square root of -25. So that's going to be square root of -1 and square root of 25. So square root of -1 is I. Square root of 25 is 5. So the answer is 5I. Next is square root of -72. So that's going to be square root of -1 times square root of 72. We're going to break 72 into two numbers. One of them should be a perfect square. So the highest perfect square in 72 is 36 times 2, because 36 is a perfect square. So now you're going to get I. Square root of 36 is 6, and then inside would be 2. So the answer is 6I square root of 2. Next you have letter C, -5 square root of -1 times square root of 9. So that's going to be -5 times 3I. Square root of 9 is 3 and square root of -1 is I. So the answer is going to be -15I. For number 1, the square root of 4 is 2 and the square root of -1 is I, so answer is 2I. For number 2, you're going to break 12 as 4 times 3 and square root of -1 is I, square root of 4 is 2, 3 inside, so answer is 2I square root 3. For number 3, you're going to break 54 as 9 times 6, square root of 9 is 3, and then square root of 6 inside. So this is going to be 2 times 3, 6I square root 6. A complex number written in standard form is a number a plus bi, where a is real part and bi is called imaginary part. So if b is not equal to 0, then a plus bi is an imaginary number. So for example, any number where you have a and you have a b, so 3 plus 4i, that whole number is called imaginary number. If the number a is equal to 0 and b is not 0, then a number is called pure imaginary. So for example, just a number 4i where there is no real number, because real number is a, that is 0, that type of number is called imaginary number. Now we're going to discuss real numbers. We have learned about real numbers in the past. That has two branches. One is rational number, other one is irrational numbers. In rational number, you have all the numbers that are decimal, negative, positive, and fractions. Irrational numbers are the numbers that are the type of pi and square root 2. The decimal for these numbers do not stop or do not repeat. Now for imaginary numbers are the type of number 2 plus 3i or 5 minus 4i. Pure imaginary number means the number that has no real part, so just 3i or just negative 4i. Now let's discuss example number 2. Equality of two complex numbers. Find the values of x and y that satisfy the equations 2x minus 7i equal to 10 plus yi. Now you're going to set real part equal to each other and imaginary part equal to each other to find x and y. Now 2x equals 10 because they are real parts, so 2x equals 10, and then you divide with 2 to find x value, so x equals 5. Now we're going to equate the imaginary part with the imaginary, so we're going to have negative 7y equals yi. Divide both sides by I to isolate y. You're going to get negative 7 equals y. So y equals negative 7. You're going to try number 5 and 6 and match the answer. For number 5, I equate the real part with real part. So x equals 9. So we don't have to do anything. The value is just right there. For imaginary part, I equate the 3i equals negative yi. Now we're going to solve for y. It means we need to divide with I and divide with negative. So to remove the I and negative with negative, you got the y by itself. And here I and I cancel, so y equals 3. Number 6, the real part equals 9 equals negative 2x. So divide with negative 2 on both sides. You got x equals negative 9 over 2. In this case, what I did is differently from these questions is that I did not write the I next to the imaginary number, but I equate the imaginary part rather than equating the imaginary number, because I know that the I is going to cancel with the I anyway. So you can just write 4y equals 3 and divide the 4 on both sides to get the y by itself. Now we are going to discuss the sum and difference of complex number. To add or subtract two complex numbers, add or subtract their real parts and their imaginary parts separately. Sum of complex number is just like the same way you're doing the other addition and subtraction. So all you're going to do is to add like terms. So a plus c plus b plus d. So like terms together on the subtraction as well. So a minus c plus b minus di. For letter A, you're going to add 8 and 5 because they are like terms. So 8 plus 5 is 13. And then you're going to add negative I plus 4i. That is going to be 4i minus I is 3i. So 13 plus 3i is your answer. When you're subtracting the two complex number, make sure you distribute the negative number inside first. So it's going to be 7 minus 6i minus 3 plus 6i. combining the like terms. So 7 minus 3 is 4, and you can cancel the 6i with negative 6i. So answer is just 4. For next number, letter C, you're going to distribute the negative inside. So it's going to be 13 minus 2 minus 7i plus 5i. Combining the like terms, you're going to get 11 minus 2i. For number 8, you're combining the like terms. So 9 minus 6, negative I plus 7i. 9 minus 6 is 3, and negative I plus 7i is 6i. So the answer is 3 plus 6i. For number 9, you're going to distribute the negative inside first of all, and then combine the like term. So that's going to be 3 minus 8, that's going to be negative 5. 7i plus 2i is 9i. For number 10, first you're going to distribute the negative inside for both the brackets. So it's going to be negative 1, negative I, and this is going to be negative 5, negative 9i. Remember, whenever you see a negative sign in front of a bracket, you always first distribute that negative and then combine the like terms. So that's going to be negative 4 minus 1 minus 5, that's negative 10. Negative I minus 9i is negative 10i.